So right up there we have a conic section called the hyperbola. All right, hyperbola. Is it hyper? I don't know. But we have F1 and F2, those are foci. V1 and V2 are the vertices. And this white dot here we'll call P, a point P on the hyperbola. Watch this. Let's see what hyperbola actually is, right? We're going to take the distance from F1 to P like so. We'll put it horizontally right there. We'll take the distance from F2 to P. We'll put it right there. If we subtract those two distances, believe it or not, we'll get the distance between V1 and V2. Interesting. What happens if I put this point down here? Let's look at F1 and F2 again. If I subtract those two distances, right? See, F1 to P minus F2 to P, that distance is also the distance from V1 to V2. The length of the hyperbola is what we call transverse axis right there. Even if we put it way down here, let's think like, oh my gosh, whoa, that's crazy, flipped around, right? But see right here, the distance from V1 to V2, right? Move it right over there. We'll take F1 to P, right there, F2 to P, right there. Subtract them, we get a constant. So a hyperbola is a set of points in the plane, right? So that for any point on the hyperbola, the difference between the distances between that point and two fixed points called foci, that difference is always a constant.